Find the seismic design force of the billboard, FP, in kips. In this problem, a billboard is attached to the roof of a building. The weight, the site class, and the short period spectral response acceleration are provided. The seismic design force on non-structural components, FP, equals 0.4 times the component amplification factor, AP, times the short period design spectral response acceleration, SDS, times the weight of the component, WP, divided by the quotient of the component response modification factor, RP, divided by the component importance factor, I, times the quantity 1 plus 2 times the component height, Z, divided by the structure height, H. We'll first determine the component amplification factor and the component response modification factor by referencing table 13.5-1 in ASCE 7, an excerpt of which is shown here. Signs in billboards are assigned a value of 2.5 for both AP and RP. The component importance factor, I, equals 1.0 for all components, unless the component is used for life safety purposes, contains hazardous materials, or is attached to an occupancy category Type 4 structure. Therefore, the billboard atop the building is assigned a component importance factor of 1.0. The short period spectral response acceleration, SDS, equals 2/3 times the short period site coefficient, FA, times the short period spectral response acceleration, SS. The problem states that SS equals 0.8. The short period site coefficient is determined using table 1613.5.3, number 1 in the International Building Code of 2006, with knowledge of SS and the site class. Since the site class is type C and the short period spectral response acceleration equals 0.8, we'll determine the value of FA by linear interpolation between 1.1 and 1.0. After plugging in the value of 0.8 for SS, the short period site coefficient equals 1.08. Now we can solve for the variable SDS by multiplying 2/3 times 1.08 times 0.8, which equals 0.576. The problem states the weight of the billboard, WP, equals 5 kips. And since the billboard is attached to the roof of the building, the component height, Z, is equal to the structure height, H, and therefore this last part of the equation equals 3. With all the variables on the right-hand side determined, the seismic design force, FP, equals 3.45 kips. When reviewing the possible solutions, the answer is A.